In this lesson, we're going to talk about the lifetime of objects and object references and how the .NET Framework runtime manages the memory that your objects use. So take a look at cs-asp_038. You can pop it open. It has a cars class and a default.aspx.cs file with one line of code. We're essentially just creating a new instance of the car class. But what's really going on here? Well, once we execute this line of code, the .NET Framework has to go to work to create a spot in the computer's memory large enough to hold a new instance of the car class. The computer's memory has addresses, just like you have addresses, for your apartment or for your house where you live. And these areas in memory that have addresses are where the .NET Framework runtime temporarily stores values like objects or variables during the lifetime of the variable or the object, depending on what you're creating. So the .NET Framework creates a place in memory large enough for the particular data type, in this case, a class instance of car. It takes note of the address where it put that new instance of car, and then it serves that address back to you, the programmer, so that you can get back to that information in memory whenever you need it. So my car, in this particular case, the my car moniker, the object reference, it simply holds an address, a reference to the instance of the car class in the computer's memory. So whenever you need to work with that instance of the car class, you just use the my car identifier, and the .NET Framework takes care of the rest. It gives you the illusion that you're actually working with the object itself, but you're really just holding on to a reference, okay? An address. So actually, I think there's another way that we can represent this to help you understand how this works. We can break this one line of code down into two lines of code. Let me just comment this out, and let me show you that we can create car, my car, and then on the next line of code, my car equals new car, all right? So this one line of code that we've been writing up to now is just a shortcut for these two steps. We're just taking them all in one step instead of two steps. So that first line of code, car, my car, we're creating an object reference, something that can hold on to an address, but it currently is not set to anything in memory. All right. In other words, we have a handle, but it's not attached to a bucket yet. All right. In the next line of code, car equals new car. At that point, the .NET Framework runtime creates a new instance of the car class, and it returns back to you an address, and you stick that address into the moniker called my car. Now you have an address, a handle to the bucket in the computer's memory that's holding a car class instance, a car object. All right. And so we've used this bucket analogy several times already up to this point in our series. Whenever you store an object in memory, .NET gives you, the developer, a handle so that you can hold on to the bucket. If you let go of the handle, you'll no longer be able to retrieve the bucket that it was formerly associated with. The bucket will no longer be accessible to you, the programmer, to your application at that point. But why won't it be accessible any longer? Why does it go away? Well, the .NET Framework runtime cleans up memory every once in a while by counting references. So if we're no longer holding on to a reference to an instance of the car class, then it deduces that, well, he's done with it. I mean, if he wasn't done with it, he wouldn't have let the references go, right? So at that point, it's going to remove the instance of the car class from memory, just destroy it, get rid of it completely, and it's freeing up space so that it can use that area in memory again in the future for some other purpose, another instance of a class that you want to create, or some variable, or whatever the case might be. And this process, this cleanup process, is called garbage collection. And there's a part of the .NET Framework runtime that's called the garbage collector, and that's its job. It goes around and counts references to objects in memory, and if it looks at a given object in memory and says, how many references are holding on to you right now? And if it says 0, then it removes them from memory. Okay? Kind of to extend this a little bit further, let's have some fun with this idea. Let's get this back to that line of code, even though they're roughly equivalent. And so what I'm going to do is this: car, my other car equals my car. What in the world did we just do here? Well, now we've copied the address that holds on to the value of my car holds an address. We've copied that address into a second handle, a second reference called my other car. Now we have two monikers holding on to the same address in the computer's memory for that instance of the car class. All right? So now we can use either handle to retrieve the data in the bucket in the computer's memory, so to speak. Another analogy that you might prefer is it's like a string to a balloon. Say you have a balloon, you got like 3 strings attached to it, and one by one, use the scissors to cut each string, and on the last string that you hold on to, snip, the balloon floats away, and you can never access that balloon ever again. And so it's that same idea. Now, when does this actually happen in C#, in .NET? Well, in two situations. First of all, whenever a reference goes out of scope. So in other words, when we are executing the lines of code inside of page load, and we've got these two object references to that new instance of the car class up in memory, at some point we're going to exit out of the page load method. So our line of execution, our thread of execution exits out the bottom closing curly brace and moves on to something else. At that point, it destroys those two handles to the bucket in the computer's memory. The second scenario is that we can manually do this ourselves. We can destroy the reference by setting it equal to null. I'll show you that in just a moment. But whenever those two things happen, the number of references or the number of strings that are holding onto that balloon are removed. The reference count is 0 now, and the garbage collector will just remove it from memory, and you can never get back to the state of that object any longer. You can create new objects based on the given type, the data type car in this particular case, but you can never get back to that instance of the car class. Okay? All right, so we said that whenever the thread of execution leaves the current block of code that we're in, that's one scenario where the object references have been removed, but we can take control of this as well, and this is generally considered to be a best practice, is to do something like this. My car equals null, and so the null keyword means indeterminate. It doesn't mean nothing, it just means that we're removing any of the values, and now we don't know what my car is set to. All right, so we essentially clear out the address. We're no longer holding a reference to that object in memory any longer using the my car moniker, the my car identifier. We still hold one reference now after we execute this line of code because my other car is still holding on to a reference to that car object in the computer's memory, but we can set that to my other car equals null. And after we execute this line of code, then the reference count goes to 0, and the next time the garbage collector comes through, it will clean up and remove this car object that was created in the computer's memory with the new keyword. All right. Now, just to be kind of specific here, you might wonder, and I've been very loose in my explanation of when the garbage collector gets around to it, all right? At some point, the object references will be removed whenever the .NET Framework gets around to it. In some situations, this is an indeterminate number of time, and some have seen that this causes problems for them, especially when the object in memory is holding onto a system resource like a network connection or a file in the file system, or holding on to a handle to access a database. All right, so those are bad scenarios where you want to force garbage collector to remove the reference because you want to clean it up so that you can possibly use it again in the next fraction of an instant. All right, so in these cases you might want to take a more deterministic approach to requesting that .NET remove the object from memory, and if necessary, finalizing any cleanup procedures. Now in these cases, if that ever happens to you, and we'll get into this more when we actually talk about working with databases or working with the file system, whatever the case might be, then you want to learn more about this terminology called deterministic finalization in .NET. So it's a bit more of an advanced topic. We're not going to cover it in this series, but a quick search on the internet will provide plenty of discussion about what it is and the scenarios where it's important. Okay? So hopefully this helps you understand better what actually happens and the lifetime of an object. the use of the new keyword, what actually happens when we create a new instance of the keyword, the notion of references, that we're holding onto addresses to objects in the computer's memory, and that whenever we let go or set those references to null, or the thread of execution exits beyond the code block, any of those scenarios, we will remove all references to the object. The reference count goes to 0, the garbage collector cleans it up, and the object has now, in just a few lines of code, been born, lived its life, and now has died. Okay? So that's why they call it a lifetime. All right. So hopefully that's helpful in your ongoing understanding of classes and objects, and we'll keep building on that in the next lesson. Thanks.